Fantastic. Thank you, Jacqueline, for this introduction. That was very kind of you. Can you see my slides?
I can, yes.
Amazing. I sent you the slides in the chat for the people who might want them immediately. And let's start this. So, hello, I'm Lada Kessler. This is a talk about coding with AI. I want to start with sharing my experience of what it felt like this year for me to code with AI. So, Ken Beck has this amazing analogy that I really, really like that kind of summarizes up really, really well. So he talks about a coding genie. There's this genie. And this is not your genie from the Disney movies. No, this is the genie from the books. And the genie from the books is mischievous. So you come to the genie and you're like, hey, I'd like some software. And the genie pulls out the laptop, goes to work, does some magic, and out comes working software. Well, mostly working software. Often works, maybe. And then it kind of shows you the diff. You look at it and like, I guess it looks fine. And you're like, sure. And that's kind of what it felt like this year to code with a genie. So like how you feel about this depends of your role a little bit, right? So if you're a product manager, you're like, yeah, and right, because this is like normal life. You go to a developer, you wish for some code, and sometimes what they produce works. For the most part, it does. But for a developer, it's kind of mind-blowing, right? So it kind of felt like a new territory to me, and the one that needs exploration, and the one where we maybe need to ask questions about what do we know, and is it still true? So I've been exploring this year, and the question that came to mind, like first and foremost, is how on earth do we tame this? Right? So to be able to control anything, it's helpful to think about what on earth can you even control? What levers do you have, right? So what can we control here? Well, we are here, we're a developer. We can control ourselves for the most part. And there is a foundational model. This is basically the LLM that is spit out every other week by Anthropic and the like, right? ChatGPT and so on. And pretty much like this is like a volcano spitting out those LLMs, and like they new every week. And then in the middle, like they need to talk, right? So to be able to talk, to be able to work, you need something to talk to. Used to be a browser, now it's an agentic IDE or something I don't even have the name for, Claude Code. So like a coding agent, right? And what you can do on this level is you can kind of choose that. I prefer the best ones. And that kind of maybe determines of like what kind of foundational models you get with that. And then you can configure it. So AI comes with kind of default behavior that is not very helpful, and you can tweak it on a certain level. And like agentic coding tool allows you to do that. You can give it tools like MCPs, or you can build your own tools. You can navigate it, go there. Don't do that. For the most part, don't do that. And then you can automate some of that, right? So this is like roughly our territory. This is what we have. What on earth do we do with this? And given that that genie is mischievous and treacherous, so I've been exploring this year, and this is what we're gonna go through. So people who are coding a lot with AI are saying kind of the same thing. It's really hard to explain this stuff and show this stuff. So the take I took on this is I'm just gonna try to distill it into patterns. And patterns are nice because you can combine them. You can maybe use several of them at once, and they kind of help you think through some things. They are my patterns, right? So this is what I came to. It works really well for me. When I code with other people, it seems to work really well for them too. So I'm going to share those with you, and I hope that they will be helpful. Yeah, so there's lots of patterns in this talk. Don't panic, there's resources. So I'm going to stop on this page for a second if you want to pull the phones, or I already gave the link in the chat, so it's the same thing. You can do several things here. You can grab the map from it. On the resources slide, you'll find the map, and if you want to follow through, there will be a map. There's going to be 2 pit stops. I'm going to stop after each peak session and take questions. All right, let's continue on. Right. So it's really helpful to understand some constraints when you work with AI. And so let's talk through some of those. So the biggest one that we will face first is that LLM cannot learn from you. So the model weights are fixed and it is stateless. So the people are like, wait, what? That's the main purpose of LLM, right? They learn. But the one you get is like frozen in time. The weights are fixed. You can't, by talking to it, change its mind or make it actually write good code. It would be lovely if it could. Um, and at the same time, it's stateless. So let's talk about stateless. What do I mean by stateless? Um, so memory is a lie. The memory you get is a lie. If you actually talk to a real LLM or like underneath LLM, they're all real. With underneath LLM with the API, what you get is this. They're basically like, hey, what's 2 plus 2? AI is like 4. What's that in Portuguese? And I was like, what in Portuguese? Because really what it sees is one message you send it when you talk to through your API, unless you implement the memory layer. And when you get that back, you're like, yeah, not very helpful, not very good user experience, right? So what all the systems pretty much starting from the browser are doing is pretty much this. So there's a concept of context window. And this is like, you can think about it as a giant string and you just concatenate stuff to it. So the experience with context window looks like this. You ask the same very smart question again. Um, the genie looks at it, well, for dummy, and then what's it in Portuguese? And so what happens here on this level is this is your no prompt. So what is sent to the genie at this point by the tool is first message that you sent, and then the for, and then the last thing. And because it sees that what is it in Portuguese, and because it also sees that what's 2 plus 2, it's smart enough to say, well, still for dummy, right? And this is basically your context window now. So your context window after this force interaction is this. And like I said, pretty much like string concat and pretty much immutable like string concat. Um, so we are dealing with something that has weights we cannot touch and that has context. And the context is unchangeable and clonable, right? You can add to it and you can reset it. You can start from scratch at any point in time. So how do you control context, even just those 2 operations that you actually have, right? You can do it manually or via tools, but let us look into it. The next problem we're going to face with context is oftentimes people think about context as this uniform, so this giant string, right? But it's not really a uniform string. So context degrades as conversation progresses. The LLM stops following instructions, and that actually happens long before you even reach the limit. So what it looks like is basically this. This is what the context kind of is, or it's not to the scale, but to give us the general idea. So you start from good, right? You're in a very happy zone, everything is peachy, instructions followed, and then it starts to get a little worse, but it's like very workable still. Like it's still fine, and then it just plummets to death. And like your experience, depending on when you ask a question, will depend on when you ask the question, right? It won't be the same performance. So performance degrades pretty intensely with the context. So that leads us to context management. We need to manage context. We need to think about it. We can't just shove things in there with unthoughtfully. So we went through AI cannot learn and the context rots, and we need to manage context. Now, how do we manage context? Well, that leads to pattern number 2, knowledge document. That's very simple, but very powerful. So the first thing you do is on the left, there's this kind of example of a context window. It's filled with all kinds of stuff, some good stuff, some bad stuff. There's just gems there. The green things, the 3 green things, are like the golden pieces that are like very valuable to you. You spend time giving it to it. You explained your TDD process in detail, corrected it. You did something else that took a lot of time. It's a lot of goodness. And now you're kind of at the end of this life cycle and you like kind of have to reset, right? So how on earth do you reset? It would be really lovely if you could do this. Give me this clean context without this garbage and just my 3 golden pieces, right? So you can do this with knowledge documents. So knowledge document is that pattern. Basically, you take the goodness You save it to a file, very simple. And then when you reset, you have a file and a new context, right? And it's easier to hit reset now because you have that. So again, you have knowledge document and the thing. You hit reset. After you reset, you basically say, load the important bits, right? So that's your first action, load the important bits. And now you have a lot of goodness and a lot of freedom to do more things with this goodness. So that's nice. So this is so important that that leads us to button number 3. And some systems started to actually implement this by default. That wasn't a thing, I would say, still since April, like that's April-ish when I saw it first. So they started implementing ground rules. This is a thing that is always pulled in. So Windsurf has one of those rules files. Claude Code has one of those. Many things have those. So the idea is simple. When you open your IDE or your like Claude Code, basically it just pulls in the stuff you put into it, you told it to care about, right? And it's just there by default always. Those are the best things you can think of that you always want on. And we can talk about what goes there later, but mostly, like most important things in life for you go there when coding with agentic AI, right? And those can be on user level and a project level. So everything you care about in general on your computer or in a project. So then how do you get those files? So how you create files that are like not either that or other files, right? You can use extract knowledge. It's kind of like extract variable. You have this dirty context. You have a genie. You don't have really easy access to this conversation. You might, but it's a bit tricky. Knowledge is scattered and so on. But you can ask Genie. It's like hit save, and Genie saves it to a file for you. There's a little bit more to this. We can talk about some of ways to manage that a bit later, but that's pretty much the idea. So you extract knowledge by whenever you have a dirty context and you don't want to repeat this the next time, ask it to save to a document. And we'll talk where and we'll talk like what kind of document in a second. But that's really, really powerful, and that stops you from being a human copy pasta machine. That's the most tiresome and annoying part because pretty much like AI has no memory, so you have to be its memory. And that's exhausting. So save yourself some energy and save things to the files. And then you can create those and modify, right? If you did something to adjust its behavior, you can also modify and have it save. Saves a lot of energy, makes a lot of difference on actual projects in reality. So then next question, can we put everything in one file? Well, first of all, no, because it won't fit, probably. I mean, unless you don't have much things to care about in life. So context has fixed size, first in, first out, and then everything competes for this space. That's your limitation. So like just to be briefly, like what are we talking about context size, right? So we're having the same wonderful conversation as before. We're filling the context, and say this context is very small. So at the end, like we reach the end, right? And we're saying something else. Well, it won't fit. So there's different systems that do different things here. So first of all, we need to put it in. And then what do we do with that stuff? So it's either dropped. That's the thing that Windsurf, I think, started like did early on. I don't know what they do now. The whole conversation get compressed potentially. That's Claude Code's behavior. And they warn you in advance, which is very nice of them. And if you're working on the level of the API, it just like says, stop it. And errors out. So limited context window, right? But the problem is it's not just limited. So here comes the distracted agent. That's an anti-pattern, number 5. So I have those rules. They have been with me forever. And it started with, the first rule came from Elizabeth Hendrickson. So I was at her webinar and she showed me the trick or asked the tricks that says, tell me something I need to know, even if I don't want to hear it. This is like when she actually wants the real feedback. Very helpful. I liked it a lot. And I ran with it for a while. And then I thought, well, why don't I take it further? So I was like, I employ some productivity rules. And like, well, if I'm about to do something dumb, please don't let me. Let me know about this. Prevent issues before they start to be a problem. So I put it in my ground rules. And I was waiting for it to hit and for it to tell me something. And I was waiting for a long time. So I was doing everything in one agent, in one window, and I was also committing here. It's actually very nice at committing. It summarizes it up very well. So I tell it to commit, and it's like committed. And all kinds of badness went in there if I didn't look carefully, right? It committed node models, it committed a bunch of stuff. And what I was dealing with is this generalist agent. So basically, I was doing everything in one thing. And I asked it to code, I asked it to check websites for documentation. I asked it to also, this is the committer rules in there, right? Throw in like the code base, everything, right? So when you're dealing with that, kind of everything is competing for attention. So AI has attention, and everything you put in there dilutes that attention if it's a different thing. And what you see in practice is either like it's shallow focused or it fixates on something like that you actually don't think is important. So it chooses something to fixate on and does that. It's especially noticeable when you try to extract knowledge from this. So actually, like the size is not actually the problem. Well, at some point it is, but at this point it isn't. So I've seen like a longer context that is focused still behaving much better than this kind of distracted agent. So specialists is better. And I didn't realize to what degree until I saw this. So LLM has limited focus, doesn't prioritize, and I saw the focused agent. This is part number 6 for the first time, and it blew my mind. So I have Claude Code on the left. This is my main Claude Code. And since I switched to Claude Code, they kind of invite you to open several agents at the same time because, well, it's not an IDE where you have the thing on the left or on the right. Right? It's easier to open several windows. So you kind of want to, because you want to, in addition to agent, you want to do the bash stuff, and like you can just open another agent. And I was kind of already conscious about my context because I was running out of it a lot. So I started opening this committer. So this is my little committer. I open this little window and I'm like, hey, here's how you commit. And it's like, okay. And we did that for a while until I saw this. As soon as I started doing this committer agent, I saw this and I almost fell out of the chair the first time I saw it because it was like, hey, you're about to commit your entire node modules. That's a bad practice. Did you mean to do that? I'm like, oh my God, this is so helpful. Thank you. No, no, please don't do that. And the next time was, hey, you're actually violating your own rules, dummy. Like you're doing underscores where you normally doing hyphens. Did you mean to do that? I'm like, no, no, thank you for telling me. Very, very helpful. And then there's some weirdness with your PDF. Did you mean to kind of like, do you want to, does it want in or out? Like, should I unstage it or stage it? Again, like it didn't know what to do, so it told me, and I paid attention. So that was mind blowing. And I was like, why didn't it tell me before? And why is this, right? So what we're doing is we have a very focused specialist that is only focused on this thing. And my main committer, oh, sorry, my main Claude code and my committer, they have the same ground rules. They have the same rules, warn me about stuff, right? But my main one never did because of the scattered focus, right? But this one does, and this is super powerful. So small agents beat big and scattered agents any time of the day. And I'm really, really, yeah, in love with my little committer for sure. So so nowadays I run kind of like this. This is just like where I'm at right now. Sometimes more and sometimes parallel stuff. But I like kind of focusing on one thing in one place, and that kind of helps me focus. Yeah, so anything you load in your context is a takeaway, right? Is harmful. It's not just taking space, it's harming your focus. So be careful what you put in there. And that kind of brings us to references. So we talked about ground rules. So ground rules are things like put out the fire when you leave the camp. So like I have a ground rule of prefer simple solutions, very important to me. But there's other things in life that you care probably, and you still don't want to repeat. So like, hey, the test SSH thing is in the root, please run it from there. Or there's a code style guide, please follow it. There's a TDD process over there. Or I have a to-do list, follow it. Or a scratch pad. The ground rules are always on. But the rest of it basically can be pulled in as needed. So that kind of asks us, this is the next pattern, references, right? So reference docs, where you basically put the things you care about, but not the ones that are super, super important, separately into a different library. And you start collecting the library of this stuff. So what it looks like, what working with it looks like is this. So you have a context window. You have ground rules by default. You put only the most important stuff there because you don't want to lose the focus. And then you start coding with it, start filling it with stuff. And as you fill with stuff, I'm like, I need James Short nullables. I need to teach it how to do nullables. I have a nullables doc that I made. And when I need it, I point to it and say, pull it in. And now it knows how to do the nullables. That's a reference doc. So I'll use the reference. Then you fill in context. You do the same with TDD process. And when you need the test plan, you can pull it in. So the next conversation will not look anything like this. Only the top part will look like this. But that allows you granular focus and granular pulling in of what you have, what you need. So good control, which kind of brings us to like the knowledge composition, which is pattern number 8. How do you decide what goes where, right? How do you split them up? So you have a context window, again, ground rules are there. And say you have project MD and you put everything you care about in the project in there. So you have your project info there, you have your Python style guide, the JavaScript style guide, front-end test plan, back-end test plan, because you have test front-end and test back-end. And you only want to test front-end right now. If you say this, just pull it in, you kind of get everything by default. And that pollutes your context and its badness because of the focus, right? So you can't pull out individual pieces similar to the code, right? You don't want the giant function. You want to split them up so that makes you physically more powerful. Similar with this, if you do this, right? If you just put it in the front-end plan, you can pull it in individually. And that empowers you to do better in managing your context, right? So this is where we are, and I think we're stopping soon for the pit stop. But we started with cannot learn. So we can't, AI can't learn, and there's context fraud. So we need to really actively manage context. This concept of knowledge documents that's been actively used throughout the industry nowadays. And this concept of such important things that are going into ground rules that are always loaded by default, and how we want to shave out all the unnecessary noise from that. You can use extract knowledge to create knowledge documents, and you have limited context window, and focus is a scarce resource. You need to be careful with the focus, and you can do wonderful, wonderful things with focused agents. And then we have reference docs. So everything that you don't care about in everything you do goes to reference docs, and start collecting your reference docs. It makes you much more powerful. And then you can use knowledge composition to think through what goes where. Yeah, and I think the last bit before the pit stop is, so AI is really, really noisy by default, and that kind of needs active management. So, and also it really helps when you manage it to keep the documents from document rot. So here's an example. So I was starting to learn Rust, and I had my agent create me a Rust project. I know nothing about Rust. It set me up with Rust very nicely. And I was like, hey, what's this cargo tom file? That's the first thing I'm seeing it. I'm curious, what is it? And it's like giving me this. And when I see this, my brain goes like, wait, I don't care about this detail yet. I can't scan this. I don't care about that. I don't care about that. No, I really, really don't care about this. I can't. Annoying. Take it away from me. So what I do next is much more succinct, please. And that's pretty much like my default phrase everywhere at this point. So, and it's in my ground rule. So what it gives me when I say much more succinct is this. So cargo is a Rust project configuration file. Oh, it's like package.json. I understand. Oh, it has metadata dependencies, build settings. Okay, that's fine. And I can't build without it. So here, the level of detail matches the level of my curiosity. And this is just noise. So basically, you're dealing with something new. It wasn't a thing 2 years back, right? This is what I call part number 9, semantic zoom. You can zoom in and out of text now. Text became elastic. So to zoom in, you say, tell me more about the thing. You ask questions, and it goes deeper. To zoom out, I like to say, make it shorter, succinct, high level, and give me TLDR. And this allows you to, when you zoom in, to deepen understanding when you know, when you need to. And also the meaning becomes scannable when you zoom out. And that takes a ton of difference on documents. So, and just when you work with it, because, so whenever you start working with documents and extracting documentation, the first thing you probably see as you go forward with your application is it starts to do the same thing that does in code. It starts to put like outdated documentation in there and all kinds of noise. Like it reads one part but updates the other. Like it didn't update everything. So what really, really helps is look at the doc, look at the code, make the documentation, update the documentation, and make it extremely succinct. It makes it really scannable. And also in responses to you, it kind of prevents it from overloading you because it's like a crazy token machine. It will overload you if it, and many people just allow it to, and I don't think it's helpful. And then you delete mercilessly, Git is your friend. And like, I also really like to think about files as temporary and permanent and just toss away the ones that I don't care about frequently. Helps a lot. All right, and there's a few other things you can do with the zoom levels that are interesting. The one example here is just when I go to a repository, if it's a new repository, I often like, hey, give me the idea of this repository architecture on high level. I'm like, okay, well, it's just a simple thing. I understand. Like, I look at it and understand. I really like ASCII for this. ASCII is really, really powerful. It is especially powerful because it's text. AI is really good at producing it. I'm decent at reading it and it doesn't look bad how bad. Like it's a quick way to look at things and it doesn't take me away from the thing I'm in, which is nice. So I use it a lot to explore stuff and I zoom level out and use a lot of ASCII diagrams to poke at things. You can also do this in tests. I don't have this example now, but like me and Llewellyn have a talk about approval tests where we show how you can basically write tests in a way that zooms out. And with AI, it's especially important because think about a bunch of tests. Like if you open a test file, there's a bunch of tests in there, and it's hard to say at a glance, what did I test? What did I test there, right? So with approval test or like any acceptance tests that are visual, you can basically tweak them to show the test cases very succinctly to you. And now you can see what I did at a glance. And that's the difference between being able to catch nonsense quickly and so on. You can do crazy stuff with that with like if you actually wipe code at some point. I, I sometimes do. I sometimes like let it loose and then refactor after a bit. When you run into bugs, this is interesting. So you run into a bug and you don't know anything what's going on with the code. How do you debug? And it's stuck. It's telling you, I've done the thing. So what you can do is like you can ask it to explain thing on a high level, like explain the code on a high level, and you see noise and like all the bullshit very quickly. You're like, why are you creating additional objects, silly? Like, stop doing that. Like, you don't create a new repository every call. No, please. That takes it away, and then like the next silliness becomes visible and so on. So that's really, really powerful, the zone levels. I'm really glad that we have that now. That's a new power. So AI has excessive verbosity. Semantic zoom is a new thing, and use noise cancellation everywhere. It's gonna save your brain cells and your project. Because if you see one noisy developer, that's bad. But if there's four noisy developers with the noisy AIs, that becomes crazy very quickly. So I think we're at a pit stop, and I'll take questions if there's questions, and we'll do a 5-minute break because this is a big talk, and I want to save your brains from too much.
Right. I'm going to set a timer for about 5 minutes for the questions themselves, because otherwise we'll not, you won't get through the whole talk by the end of the night. So yeah, we'll take questions for about 5 minutes and then go on that 5-minute break. If you want to ask a question verbally, you can raise your hand or you can type it in the chat and I will read it out. Steve, you've raised your hand and I will unmute you, sorry. You should be able to unmute now, Steve. Hopefully that works.
Yep. Hey, Lada, good stuff. I know that the suggestions for rules, for context, for Claude is small. Same thing for Windsurf, it's small. However, Cursor suggests rule files should be 500 lines, less than 500 lines, and that you can actually chain them as well too. And even when I talked with the cursor folks, they can't tell me other than say keep it small. Um, are you suggest and it seems like what you're talking about here is AI gets distracted easily. Does Claude get less distracted for you? Have you played with it much, or does it still respond better if you keep things 5 to 10 lines?
Well, I don't keep things 5 to 10 lines. It depends, right? If you're talking about the global rules, it's about like a page or two maximum, right? And
Hmm.
you already have to fight against 1,200 lines of Claude Code's system prompt. So I'm not sure. I think I would have to play, and I think the way I would play is this. I would basically take the same model. So I didn't work with Cursor. That's the one thing I didn't actually work with. My gut tells me that they don't know what they're doing yet, although it's suspicious because they are like one of the leaders, which is kind of weird. So maybe I don't know what I'm doing. But in my experience, when I shave off the context, it's like the one thing I'm curious about is like put something in there and see how often it follows it. Because if it doesn't follow it, what's the purpose of it taking the focus, right?
Hmm.
That's the interesting bit. Like, does it catch it or does it not? My suspicion it won't, because the underneath models are the same. Um, there's some difference depending on the tool. So I went from Windsurf to Claude Code, and the difference was just dramatic. But I think that was because of how Claude Code does some sneaky things on underneath. They do some interesting things. I'm not sure. That's a very interesting question. I don't know. I
Hmm.
think it's a mistake. I think it will be better if you don't do that.
Yeah. Yeah. I think it's very interesting. So thank you, Lana.
Yeah, I agree.
There's a question in the chat from Christopher, um, which is, does context degradation or rot vary during the day as well as during the conversation with the genie? And then Jay has his hand up, and I think that's all the questions we'll have time for at the moment after Jay.
Sounds good. If you mean about the day, like, do you mean like when everybody's slamming it with questions? That's what you meant?
Sorry?
When you say does it vary during the day, do you mean like when everybody is like overloading it with code this, code that? Yeah. Well, not in my experience. So your context is local, right? It's in your machine, I believe. So you can get to it, like in Cloud Code, you can get to it very easily. So that's not a thing, I think. Like there's been a time where it was like an obligatory morning outage in Cloud Code when everybody was using it like mad because before they implemented the thing, but that's just like slowing you down. So I don't think so. Wait, so that's about, yeah, I think that's it. So basically it's like a REST call, right? That this thing does to a mutable genie out there and it just sends you a whole conversation that's stored locally in there. So I believe no, but there's interesting things around degradation of models hosted in different places. So like there was an article about how when it's hosted on Bedrock, like there was some performance degradation of the same models and so on. So there's some differences in what you're talking to, which is kind of weird. Mm.
Thank you for your answer,
Hope
Lana.
I,
I'm
I,
gonna
hope, I hope I answered the question.
unmute Jay. Jay, you should be able to unmute now.
Hi. Yeah, you talked about knowledge documents. When you put knowledge documents in your repo, do you write them for a specific agentic IDE, or do you organize them in a way that they're useful by all IDEs? How do you approach that?
That's a great question. I tend to just work with Claude Code. I recently switched to Cursor for not Cursor, God, good God, Codex for a bit when they were all hype. Nowadays, like it's back. Like they're tagging the thing very quickly. I mostly work with two. I know that there's absolutely tools to kind of do what you're talking about, and there's kind of things that translate between the different file systems. So for me, I just do Claude Code because I'm just not in the environment where I need to think about it. But you can so there's a new standard which is like this agents MD, or many IDEs are implementing that. So I think they're kind of like figuring out this part, and like maybe we need to do this more carefully with people. I think it'll merge to one thing. Jay, was there more question?
No, I think that answers my question. Thank you.
Mm.
All right. I'm going to share my screen briefly
Well, thanks. That's very helpful.
and point it at a timer. And we are going to take a 5-minute break. So get up, stretch, do what you need to. How many more patterns do we have, Lada? Like, you're muted. Oh, and you can't unmute yourself. Sorry. You can unmute yourself.
We're at 11 out of 27.
Okay,
So it's going to be another pit stop. So like one side of the way.
cool. So yeah, get up, stretch, do what you need to. We'll be back in 5 minutes.
Hey, Jacqueline, do you want to make Lada a co-host?
Yes, I'll do that because then yeah. All right, it's about a 30-second warning for everyone. We'll be back in about 30 seconds. I'm seeing a lot of questions in the channel about where we'll be putting this video recording. I'm assuming because a lot of people want to go back and review it. We add all of the video recordings to our YouTube channels. It does take a little, our YouTube channel. It does take a little while for things to get processed and everything by Zoom. So yeah, it won't be immediately, but yeah, we will post it as soon as we can. And if you would like a notification about when we do post it, if you join the Calgary Software Crafters Discord server, the link is in the chat, then you'll be able to get notified when we do that.
Do you see the right screen?
We can see your screen. Go ahead,
Is it
Lada.
the right screen? Is it the right screen?
It is the one that is showing me a slide that says stop 1 out of 2 questions so far.
Fantastic. All right, so let's continue. So that's the next series of problems around AI. So let's talk about the next step. So we talked about how to manage context, and then we need to, and we're figuring out how to do it better. So now there's a problem of this thing that we're dealing with is non-deterministic. How do you work with something that's non-deterministic? The thing that I like a lot is pattern number 11, knowledge checkpoint. So when you have something that is very likely to fail, and you know that it's likely to fail, maybe do something about it beforehand. So you're planning with a genie, you spend a lot of time. You maybe talked about it for 30 minutes, invested a lot of time. If you go and tell the genie to implement this thing directly, it likely will fail, or there's a possibility it will fail. That's enough. And then you will have to figure out how to go back. And it's not just the Git, right? The Git part is nice and safe potentially, but you invested a bunch in this context. And some things allow you to roll back, but not always. But if you want a universal way to do this, what helps a lot is basically go and make a save point before you do. So I introduced this save point before. So I plan a thing, and then I say, save it to Markdown. And it saves it to Markdown for me, and I commit. And then when I tell it to implement, whether it fails or not, it will not take me more than a few minutes to go back. And maybe I course correct from there, or maybe I do something else. Maybe but I can go back so easily if I do this. So your time is very valuable here. And there's 2 places where your time is valuable. First and the most one is your time talking to it, explaining things, right? So you can protect it by doing this knowledge checkpoint, and it makes it really, really easy to go back. This is one example from a hackathon we did this summer. So we had, on the right, there's this document we had. And the document already had some things about the project, but we wanted to implement a new feature. Before we implement the new feature, we save this information that we just talked to the genie about in the file. And there's this keyword part, right? You say, this is what we want. And this is a tiny one, right? To be fair, but still, like, you kind of get yourself in the habit, and then you commit, and then when the danger strikes, you're prepared. You have to a little bit fight with its default behavior. So Claude is like a little Labrador puppy. It's like, okay, I'm gonna go implement now, even like without checking with you. So I have to often interrupt it, like here. So I'm like, no, too early. Please save it to a file. Thank you. Right? So that helps. So that helps a little bit to kind of make it a little bit safer. But this is a pretty crazy pattern because it also allows you to make this parallel implementation a bit safer. So pattern number 12, parallel implementations. You're dealing with something that is a roll of a dice. It might fail. You want a 3 really badly, but maybe like you roll a dice and maybe it won't be a 3. Very likely it won't be a 3. What do? Well, you roll 5 die. Right? So the idea is you have a knowledge checkpoint, and it's very easy to roll back. But it's also easy to do this. So I have this so this is a game thing again, a little bit, a tiny thing. So I paired with somebody to do Ricochet robot implementations, and the thing we did was fun. This is the version that didn't work. So Ricochet robot is a little game where the robot runs around, like you can press an arrow and goes all the way to the wall. And there's supposed to be walls, so it's supposed to be a labyrinth, and the robot is supposed to be moving. Neither of that is true of this implementation. So this one failed, but I didn't just run this one. So I had a save point. So I put my knowledge, like my explanation of what I want to do into the project file and to-do file. And I saved it using the previous pattern, right? So now I have a commit with this stuff and my conversation is there. And now I can just run 3 branches in parallel. That's usually easily done. Easily is a relative thing here. So Git work tree is an unorthodox feature, but you can make it very easy. Like you can just write yourself a script once with a genie, and then it's easy. So basically, it forks your project into new folders, and kind of with an underscore or something at the end. Like you can name them different things, and then like if you're dealing with Claude Code, you can open 5 of them if you want 10. And then interesting things can happen. So there's 2 types of things that can happen. First of all, the reason to do that could be I have really complex thing. I explain this thing very carefully and it's likely to fail, but I care about the results so much that I'd like it to not fail. It will take me half an hour to implement or or maybe 2 hours or something. So I will run them in parallel. So I'm trading tokens for my time, right? My time waiting for it. And if so it runs, and if it fails, sorry, I'm saying something. If it fails, that's okay because potentially those succeeded, right? And you can pick and choose the one that you like more. And the last part is interesting because so oftentimes you're dealing with something that has like interface or something and you ask AI to reuse interface. So what you can do here is like you can combine implementations. You can look at them all and like what I do with UI is I often like, oh, I like this layout better, but this little button style is just lovely. I want this one. So I'm kind of grabbing things from all over the place. I'm like, oh, I want this thing from there. I want that thing from there. And Genie can do it so easily. So you can combine them all into one solution that is going to be much better than like one solution you make. So this thing is really powerful when used in specific place. I wouldn't do it everywhere, but it's good to know about it. So this is an example of the first, like we did 3 when I paired with a friend. And the middle one was like kind of bad. This one didn't move and like I didn't like anything about it. But this one was okay. And actually it moved pretty well. And like the logic of moving through the labyrinth worked pretty decently. And I really like the buttons on the right one. So I was like, I want to combine them. And I was curious, can I even combine things like this? And I did, and yes, you can. And you can take it to like much more powerful things. Like I did a similar thing in Hack for Good when we combined things from like a designer designed an application separately in Figma, and I stole the designs. Like she came back, we paired, and I kind of told it to steal the design. So those combination things, in addition to work trees, is kind of and next a thing that wasn't possible before, and I'm excited about it. All right, so back to determinism a little bit. So pattern number 13, afloat determinism. So when you're dealing with AI, AI is good at different things, but it's not good at deterministic things, or not consistently good at it, right? So this is also from Hackathon. So we needed to be able to show the current state of the application on the screen. And on the right, there's like a thing you can pull a phone on and get the website. But like on the left, there's this screenshot. And the screenshot, we had to update it from time to time. And like we were very busy and we needed to release quickly. So we wanted it to be reliable and quick. So the one thing we didn't do is we didn't go to the Genie and say, hey, take a screenshot of the current page using Puppeteer MCP. It has access to Puppeteer MCP. It can take the screenshot. But it's not a very good thing to do this because what if we need to do it like right before like we need to run somewhere, or like we only have 3 days. We would be spending time and energy on fixing stupid non-deterministic system. So don't do that to yourself, right? This is unreliable. So what we did instead was this. So hey, go and make me a shell script to capture a screenshot. All right, AI can figure out all the Puppeteer stuff. I don't know how to do that myself, but AI is good at it. And when I ran the script, it didn't work. But that's okay because the genie is like, oh, you didn't have the Puppeteer installed yet. I thought I did, but apparently I didn't. Well, it knows how to fix it. Very helpful. And now I don't have to spend 20 minutes doing that. Also something that Genie is good at, right? But now I have a script and I created a tool. And I can use that tool myself. That's very easy. But if I want to use it in some other frame, like in series of steps, right? I might want Genie to run it, and Genie can run it too. So, and that way, whenever I say run, capture a screenshot of stage to Genie, I have very little doubt that it'll work, right? So offload the things that Genie is not good at into scripts. Make things that can be deterministic. Gonna save you a lot of time. And making those tools is something that is just something that makes you really empowered, and can save you a lot of time, and it's just really cool that we can do this nowadays. All right. So non-determinism is a thing. You can protect against it with knowledge checkpoints. You can exploit it with parallel implementations. And whenever you're dealing with something that is repeatable, don't use Genie for that. Use good stuff for that. The code is good for that. All right. So the next problem is often described as hallucinations. AI can make things up. It's certainly a problem, right? Well, thing is, we're dealing with code, right? And the code, like, you can very easily say, is it bullshit or not? You can test it, you can run it, and it's so easy. Like in code, because it's self-verifiable, like if you're getting something that's a hallucination, that's kind of on you. You didn't run the thing that it gave you. You trusted something that you know is a liar. So maybe don't. So, and that brings us to an interesting thing. So when people are saying hallucinations, I find it helpful to stop and dig deeper. Like when they're like, something doesn't work. Well, describe me a thing that didn't work. Or when you're at a thing that didn't work, look at what's happening underneath. And I kind of find interesting things, and that changes how I work with it, and it changes my approach. So this perfect recall fallacy is actually a bug. It's antipattern number 14, and it's a bug in our brain because we're like, oh, it's like Google or something. Like we go for it to Google, so it must be like Google. And like people are getting frustrated when it doesn't load the library detail. The fact that it read the whole internet and was trained on it doesn't mean it remembers the whole internet. Right? So don't expect it to. So here's an example. I was coding with a friend, and she's a chess coach. So on the left, that's what normal chessboard looks like. But she doesn't need that. She needs a thing on the right. We needed to have a flexible setup because she needs to train kids how the chess pieces move. And she doesn't need kinks for that. She's just like, okay, like this pawn moves there, and makes kids, like she makes kids run around and like capture each other's pieces. It's very fun, right? But when we tried to implement it through the browser, or we were testing in the browser, and the AI was like, sure thing, I cleaned the board, everything is good, you can pull in pieces now. And I try, and it doesn't work. And I'm like, it doesn't work. And I try again, it doesn't work. And then I'm like, something's off. So I tell it, stop and go write this same test that you're trying to do separately, not through UI, just write a unit test for that and explore what's happening. And immediately it's like, oh, we're dealing with a problem. This library expects king to be on the board. And it probably saw this thing in the training, but like the fact that it went and played with it made it see this very quickly. So we have a problem with the library. AI didn't know, but you can tell it to go and play with the library, and then you can extract that knowledge into a thing. So if you work with something regularly or something new, you can do that, right? And that brings us to playgrounds. That's pattern number 15. So if you are stuck with something and you're trying to debug something from all the way from UI and something does not work, and you can pull back and make sure that your ground is covered, like everything is good, and you can have AI play with things, and it can help you with saving some energy and brain cells. So I have the rules specifically in CloudMD, so I have a global rule about this. Like you can experiment when you're stuck. Go write yourself some dirty code. You have a place for that, and just make sure it's git ignored. And I see it doing that from time to time, and I kind of like it. I also just steer it towards it if it gets stuck. So basically what I'm saying here is don't expect AI to know the details of special things. This is what reference docs are for. If you care about something, you work with something a lot, it really helps to give it a script or a reference doc for that. Like, or you can ask it to search. It's decent at searching nowadays. And then you can also save it to docs so you don't have it to search every time. And you actually start to collect library of good things that you know are good and work reliably. Also very good when like it gets stuck. Okay, now you research. Now you tell it to put this in the doc. And now you have a thing at your fingertips that you can use like a tool. So you're more powerful now, right? And I really like experimenting, so letting it experiment and make those things. All right. So another thing I'm seeing a lot when things get stuck is this. So they call it invalidated leaps, and that's step number 16. And actually also a very human thing to do. So I used to code with when I was very young, a new developer. I paired with somebody who made me very surprised because of how she worked. So we paired for 3 hours. We wrote some PL SQL code, and we never ran the code once. And as a young developer, I was astonished because like she's writing code and writing code and writing code. And I'm like, wait, you're making so many assumptions here. Like that thing here, do you know that it returns the thing you think? And over there's like, do you know that this is true? It's actually a string. Do you know that? So I was kind of like wondering when we were doing this. And I was not surprised when we ran it and we didn't get it to work. Like it didn't even compile because of those little assumptions. So when a human is asked to write a giant thing and is not allowed to code it, like to run it, you will also see yourself doing those assumptions. AI kind of does the same thing. So when it gets stuck, I often see this. So there's several steps, and I'm like, it doesn't work. And it checks here, checks there. It maybe even checked on step B, but it didn't check the right thing. And there was a wrong assumption here, right? So whenever you kind of have this, it's stuck, and maybe it's not that library thing, it's something else, it really helps to slow it down and say, hey, validate each step, dummy, really like check yourself, because it doesn't do it by default. I don't know why, but it can spin circles around itself and not checking stuff. It's getting better at it, but still I think it's helpful. And then I love predictive TDD. In general, I love TDD, and I love predictive TDD with Genie especially because, so I learned it from Ted Young, that variation. And what you do is like you predict that, so the code doesn't exist. You predict that it will fail because it doesn't exist. You run the test, it doesn't exist. Well, you write the test, yes. And then you write some dummy implementation and then pretend that it will work because you hard code it, and so on. So you keep doing this little predictions, and that prediction is checking yourself, like checking your mental model of what your understanding of the problem space, right? And what you get from that is you get surprised when it doesn't happen. When your prediction is not true, you get surprised. And I found that Genie gets surprised as well. And that kind of snaps it out from its stupor. So I have a TDD process where I have it written as predictive TDD. And the way I got to it is basically I made it predictive TDD with me through a thing, and then extracted knowledge to a file, and now I have process file. And I can point to this process file, and we can do predictive TDD any time of the day now. And I find that so the TDD is great because it doesn't allow the leaps, right? So you get the little checks similar to the benefit of humans, and it's actually a big hit through from in the wipe coder community, I believe. So like, people are actually getting that it actually works. It really works, which is not a surprise to us, I guess. All right, so there's another problem that you're gonna face with AI, and we're getting close to the second pit stop, but I think let's plow through this one. So AI struggles under complexity. As you increase, as you face complex things, you have to kind of manage it. And by default, AI doesn't manage it. It doesn't know how to. And that's probably my biggest problem with it right now. And the thing you do is basically manage complexity. So that brings us to pattern number 17, chain of small steps, right? And yeah. So this is here's an example. So we were doing the hackathon and we released a bunch in 3 days. So this is version number 1. And by the end of 3 days, This was version 51, so a lot of small releases. We quickly discovered that we need this version thing. You see this version 51? We quickly discovered we needed this because we were trying to test and we weren't sure if it was the old code or if it was broken. So we needed this version, right, to appear on the, like, we had a page, it didn't have the version. So how did we make it? The one thing we didn't do, and that kind of starts covering several patterns, is we didn't go to it and say, show me the version number in the config and always increment it when we make a new feature, because that will be using AI for a bad reason. Like, this violates a flow deterministic. You're relying on something for it to do something that it's not good at, which is being deterministic, right? So what we did instead is we broke this whole thing in 3 steps, which maybe seem excessive for this little one, but again, it's a good habit, and let me just walk you through it, and it shows how you can do it yourself on a harder problem. So step number 1, we need a version number. The UI doesn't have a version number right now. Let's make a hard-coded one and make it display. So I go to AI and say, hey, make me a version number, and just hard-code it to 001. It goes and does it. Hey, that's a variable, right? The only thing we're doing is displaying a variable. Super, super simple. So we added the version number. It was a small change, it was easy. Then the next thing we do is we create a script that updates that variable. The only thing it does, it looks at that variable and ups it 1. All right, AI does that, that's easy. And now we have a script. And that's also a very small and new step, so very easy to do. And then, because we don't want to rely on AI to do this, we say, hey, make me a git hook to do that, because we don't want to think whether it worked or not. We just want it to work. And AI is bad at this. So we make a git hook. And it goes and makes a git hook, and it doesn't work at first, but it's really good at figuring stuff out. So I'm like telling it what's up, and it's like, oh, you configured the git hook. Like, well, I configured the git hook incorrectly first. All right. But it quickly figured it out. Now we have a git hook. So instead of doing it all in one step, this is what we did. So we managed complexity here. It wasn't very complex, but it will be on so many more projects, right? We just upped the version number here. We created a script that updated that version number, and we made a good git hook. So this kind of chain of small steps is what you have to probably do, because AI cannot do that or it doesn't do it right now on complex projects. And the patterns you saw here were, first of all, chain of small steps. That's the breaking it up, managing complexity. You human manage the complexity. And then a flow deterministic, right? We didn't rely on AI to do things that AI is not good at. And then we focused the agent. We only did one thing at a time. And we also saved the knowledge checkpoints. So before we went to the next step, we saved this thing into a file. And it's fine on the small like stuff, right? But on the big things, it will make a lot of difference. And I think this is the last thing before the pit stop. So trick instructions. So we talked about ground rules, and we talked about how it's very important to keep them narrow and put only the important stuff for you there. But like, what I found is, even if I put some things there, they're not being followed. I narrowed everything down. It's a pretty focused agent. Still no, right? What do we do? I found some things that worked for me. I'm sharing them because they might work for you. And they're pretty straightforward. So there's 2 types. So it's helpful to understand what you're dealing with. First type is you're fighting against the agent training. And that's pretty much game over. The only thing you can do is pull out the big gun. And the big gun is forcing it. So the example here would be, first of all, if you ever wanted to have AI not comment your code, that's kind of a lost battle. Don't even try. Because at first it starts not commenting your code, and then suddenly there's a code comment everywhere. What? And you say, always don't comment, never comment my code, and you emphasize 10 times. It still comments your code. What you're dealing with here is actually something so it saw a lot of code. And most of code, unfortunately, has comments because people think it's good. So it's ingrained in it to the degree that you just can't prompt it out. It's especially visible. So this kind of behavior is especially visible so there's a whisper model. This is a lovely, lovely, amazing model. that enable us to talk to computers via voice. And I worked with it directly. And in a tool I'm using, it's already mitigated. But when I worked with it directly, it was interesting. So the model basically is a voice model. So it translates voice to text, and it's really good at it. But it was trained on the whole YouTube. And what do we have in every YouTube video? Please like and subscribe. Or go to www to do this thing and that thing over there. So what you see by default, if you don't fight it, is the model starts hallucinating that stuff on silence. So when it doesn't get anything, that's actually like, when you actually still transmit, like people talk, and there's pauses in the talks. Sometimes there's like more information than less. And if you're building an application that kind of takes that, you have to deal with those silences a bit, right? And you give this to the model, and the model is like, thank you, applause, and stuff like that. And that goes into transcription. Very hard to fight with. So it's much easier to filter that stuff out than to fight with it in the model. So this kind of ingrained behavior, just don't even try. So what can you do with that behavior? Take it out. So use force. And one way to do this is hooks. Hooks are lovely. Right now, I know of hooks in Claude Code. I don't know of hooks in other things. Maybe there are hooks in other things. I will tell you about those anyway, because I think they're stealing enough features from each other, and this is like the best feature since ice cream. I can't wait to go play with them more. So hooks are amazing because hooks are deterministic. So you are dealing with LLM, right? So you're talking to LLM, and your agentic system is over here, and it's an agentic loop. So it's pretty straightforward thing. So they're all pretty simple in design. There's an agent, it calls LLM via REST call, and it has memory and has tools. That's your agentic coding tool. There's some complications. Some people are trying to be clever, but not much else right now. And it's pretty powerful. They basically, so Claude, Anthropic, allowed you to hook on into different pieces of this process deterministically. So this is a software, right? The only non-deterministic bit is this, the REST call, this part. The rest is pretty much code, right? And if it's code, you can hook up into different parts of it. First thing that comes in is your information. You tell it things, hey, go write me a Twitter, right? And goes and does stuff. And so the first message is a thing that you can hook into, right? That's an event. And you can hook up into start conversation event. And for example, the one thing I did with that is Claude Code doesn't have easily exposable conversation IDs. So I kind of hook into that because it comes from a hook. I can steal it and then I can even show it on the conversation if I need to. I need it for a thing. You can also do other things. And you can have crazy visibility into what your agent does with this. And you can also take out comments. So this is what it looks like. So this is me messing with my agent because I already have the hook in. And I'm like, hey, please add a comment. And it's like, sure thing, here's a comment. This is a hello world. That's as useful a comment as I usually see them. And then the Claude Code screams at it. Because I'm using an edit tool, so I'm hooking into edit event. And my hook is running a simple Python script. And that script is learned, I taught it to recognize comments. I use AST. I highly recommend to use AST for that because regex for comments is not amazing, but it's a bit tricky because it depends on language. So this thing screams at it, and then the agent is like, uh-oh, sorry, okay, I'll take it out, I guess. So that's the most reliable way. And you get two things at once. You also get a reminder, don't put comments in my code by this, because it gets screamed and it behaves for a bit. Doesn't last forever, but like you have something reliable, and this is actually keeping comments out of my code pretty well. So that's good. And then another way to kind of lightweightly make it behave better is just keep reminding it, because it has a recency bias. The things that you told it recently, it values more. So it's kind of nagging, right? And you can do it in a few ways. This most simple thing on the planet is to-do lists, and it's not surprised that all the tools I know have the built-in to-do lists, because this is a difference between hey, buy 10 things in the supermarket, and I just tell you, versus here's a list, right? You can look at it. Same thing. It focuses the agent. So to-do lists are really cool. Basically, very simple idea. The next thing is instruction sandwich. So very simple. You take a thing. So this is a giant to-do list. It's like implement 3 services. Okay. So I care about the stuff in between those those blue lines, right? So this code. This is implementation. But I had run tests before and after. And this is an instruction sandwich. Like whatever you care about, if you want it to be reliably done, just telling to the agent doesn't work. But if you put it in to-do list, it will be 95-ish% better, right? So another test sandwich, very simple. Another thing they can do is kind of automate those kind of reminders. So instead of you nagging every time, you can tell it every time, don't put comments in my code with every prompt. But you can also automate and use hook for that. So I wrote a little Claude Code reminder hook. And what it does is under the hood, it just tells it the most important things in life for me. And I limit it to 5 things, no more than that, because of context rot, right? But at every time it tells it to do what I care about. And this is the only thing that actually consistently makes it not ask me all questions at once. So I'm like, when you have 10 questions, give me the full list, but then ask it one at a time. That's the only thing that actually makes it stick it very reliably. So that's what we went through. So we are non-determinism and how we can make them a bit more reliable and how to make them follow instructions a bit better. And that brings us to pit stop. And first of all, questions. So
There's
questions.
one chat, which I'm going to read out right away because it got asked a while ago. But if anybody else has a question they want to ask, please either raise your hand or type it up in the chat. We'll take another 5 minutes to ask and answer questions. So in the chat, we have a question from Zed. In the knowledge checkpoint, do you start a new conversation with just the checkpoint files? If so, is this more like a point in time summary rather than the full context up until the checkpoint? I'd imagine that results, it really depends on a good and to get good results, it really depends on a good and comprehensive summary. Probably still useful, but maybe not strictly like a video game save point.
I think I need to read that because I didn't quite catch it. 1 second.
Yeah.
So do you start a new conversation with just the checkpoint files? It depends, right? It depends how big my stuff is. So I can absolutely start the knowledge checkpoint with just the checkpoint files, and it's kind of judgment call. So with AI, I find that it depends more than ever. So I can, right? So I can very easily, and also like if I fork, that's a new checkpoint file. I can clear my context. I tend to not do that. I can start a new conversation. If I want results to be really good, then I would start a new context. Point in time summary rather than full context up until, yeah, it is absolutely a point in time summary. Yes, it's basically like taking the things you care about up to this point in time of the context, putting it somewhere, and then you basically roll it out. It's not full context by any means. It's not full context. It wasn't planning to be a full context. So it's like take the stuff you care about, save it, and then you can when it fails, you can point to that again. But you're not trying to save your whole conversation. Like if you're trying to save your whole conversation, that's doable depending on what you're dealing with.
Right.
Yeah. Yeah, I hope I answered the question. If you have more questions about it, if I didn't answer, please let me know.
That's good. I think Christopher is asking a question in the chat. Why git ignore your playground files? Won't they be useful later?
Well, they're on your computer, so they can be useful later if you want to. Like if you actually care, why? Because noise. So it's a playground for the genie to do crazy stuff in it, and it's helpful that it's isolated from me. If I find something useful, I think what I do is I don't look at those files. I tell it, you learned something from your experimentation. Go save it in a file for me, right? And that becomes my point. Like I put it in a thing that I just do / command, and like I have a file to point it very quickly. Yeah, does that answer the question? So like you could if you wanted to, but usually like it's for garbage reasons because I'm trying to not be tolerant to any noise and garbage. And if there's something useful, I extract, and I usually delete the contents regularly.
So it looks like you answered Christopher's question. There's one question from W. Gomez, and then we'll take our 5-minute break. This question is, have you used a solution like Byte Rover that stores learnings, or what they call memories, in a database that the LLM can reach by using an MCP server? Sounds like a good middle ground between having a lot of info in your agents.md and leaving important things out.
Uh, it kind of gets me to lightweight, and so this universe have become drafty and lightweight and no UI to the degree that there's never been before. So text is everything. Those little agents are super simple, but they can do so many things. So it's like database is a barrier between me and that. I want it to be at my fingertips. If I want to go edit it, I want to go and edit it. And forcing me to go to database is annoying. Like you might have a reason to do that. I just don't. But if you're dealing with something, if you're dealing with a team, maybe you want to do that or something like that. I've seen things like that. I've seen swarms, like swarms do that a lot. I think it's in the way for me, so I don't use it. And plus MCPs are tricky, right? So unfortunately, so MCPs are not a bad idea. The one design problem with MCPs is it cannot be lazy loaded. So anything in MCP is basically by default in your context. And in combination with poor design, you get a lot of noise. So I know that AWS started like using a lot of MCPs, and they're like, "Where's my context go? Why am I running out of context so much?" And also like, why are my agents really bad? Because MCPs just gives you all the stuff about how to use it, whether you want it or not, like whether you care about the tool or not in advance. So it takes that space. Same problem with Cloud Code agents, unfortunately. I wanted to love agents, but I don't because of that. Taking too much space in my precious context. So yeah, I don't know. I don't do that. I think it's helpful to be super lightweight. Like I keep my tools more lightweight than ever before this year. I don't know.
It looks like Steve has a few follow-up questions. I'm going to say you can choose to answer them in the chat if you want to, Lada, or you can answer them later. We're going to put the 5-minute break timer on right now.
Yes.
Yeah, we'll come back in 5 minutes.
Sounds good. Thank you. Are you gonna put the timer? Oh yeah, thank you. All right. I'm hoping the little pit stops help manage this craziness. I know I have a lot. Awesome.
Feel free to get going, Lada. Sorry.
No. Oh, okay. All right, it's not much left, but let's plow through it. So we talked about how management of context is really, really important with those genies. We talked about the fact that they're not deterministic and what to do to make them a bit more reliable sometimes. So the next area is more about like how you work with it and what you can do to do more things more efficiently. And what helps to understand, I think, here on this level is there's two things that I think about as in combination that are really, really good to understand and be wary of. And it's like, in ancient mythology, there's like there was a monster on the cliff and then something else on the other side, and you had to like try to navigate, and if you're not careful, be eaten by one or another. So these are those. This is what I think in my head when I see those. So, well, you're dealing with something that you don't know how it works, right? In the code, you can open it up and see what's there. No mystery. With this thing, unfortunately, it has something like a mental model. I won't call it a mental model, but like, quacks like a duck. And misalignments here can be really painful and it's hard to detect. So in addition to that, the next monster on the right side of that cliff is it's also trained deliberately with a bias put in to obey you and be silently obeying, right? Which means that you have a black box that is very mysterious and you need to do something about it. So a black box AI with compliance bias. I don't know how to pronounce the names of the monsters in English, but those are that. And that leads to an anti-pattern that I see sometimes that is hard, that's like mind-blowing every time, right? I call it silent misalignment. That's anti-pattern number 20. So it's a bit not awesome to see, but there is this application, and I was working on the front end part of it, and the functionality was working, but I was very unhappy with this, right? So on the left side, there's voice transcription. It's not level with the incident report form. And finally, I got the logic out, and I'm like, okay, now let's fix it, the UI, right? And I'm like, hey, can you please make them like level? So there's left side and there's right side, and there's top part on the both, right? I want the top parts to be the same, please. Same size. Level them up. And AI goes away and it's like, sure thing, boss, and does the thing. And it doesn't work. I'm like, well, it's not working. Can you fix them for Rails? Like, sure thing, boss, right? And to me, what I see is this, right? This is the top part. They're not evil. They're not level. Sorry. And then the bottom parts are kind of the same, like not the same size. I want them to be the same size on both sides, please. Thank you. Right? Straightforward, not hard. Should be simple. Like it's simple to me. I don't know why it's not simple to it. So I go to it and like suddenly I have a suspicion. And I'm like, hey, friend, when I say the top part, can you just like go and color those pieces for me? And I see this, right? So actually it has a different idea of what the header part is. It thinks thing is empty, but in my universe, it has a microphone in there. And in this thing actually, it thinks that this incident report form belongs to this what's a name thing. And it totally doesn't. But as a human, I know that, but it does not. So once I saw that, that was pretty trivial to fix. But what wasn't trivial is to detect. And the next question that I have from this is, why on earth, when I told you about the top parts and the bottom parts, you didn't tell me what? You don't tell, I don't quite understand you, human. You're making no sense in my universe. Please, can you explain? Thank you. That didn't happen. And this made me wonder why. And that made me think that I need to do something about it, right? So that made me implement the ground rules of, well, maybe let's tell me when like I'm being silly and I'm saying something that doesn't make sense in your universe instead of saying sure boss, right? So I did those things. So first of all, hard to even suspect, right? When you run into it, it's hard to even suspect that something's off. I see blocks as a human. It sees divs. I don't make sense in the universe when I say fix the headers because it sees divs, there's no headers. It doesn't tell me that because it's like, sure thing, I'll give you the moon and the stars. Not helpful. So that brings me to the pattern 21, active partner. So I try to give it liberties. You have to suppress the default behavior of compliance and silence, right? This is where this tell me something I need to know if I don't want to hear it is in my ground rules. I also have pushback when something seems wrong, don't agree with mistakes. I also have ask questions if something's not clear. And especially if you need to make a choice, don't just choose randomly and then whatever. And then I also like this. So when you show a potential error or miss, tell me that you see that something is off. And when I see this emoji, I know that this rule worked, which is nice. So basically, how do you enforce partnership like this, right? So you can have things in ground rules, and you could maybe invent new things you could put in ground rules that are going to be helpful that we didn't think about yet. So I put honest feedback, permission to disagree, proactivity. Love the proactivity bit. And then whenever I also reinforce it with prompts, right? So I wish it was easier to reinforce. So my little reminders thing actually help a lot and keeping it more proactive. But I also prompt impromptu. So whenever when I actually want a feedback that is better than this is awesome, right? I ask it, what do you really think, honestly? So I reinforce. And then, do you have any questions? Is something I do every time pretty much I talk. Like I give it a thing and like, do you have questions? And I don't say, give me 3 questions. I say, do you have questions? Because it's actually like if you say, do you have 5 questions? What if I had 8 and the 8th one was the most important bit? You're suppressing something for no reason. What if you actually didn't care about, like, what if it had 3 and you said 5 and it just made up things? So like you're wasting your own time for this. Like those like arbitrary restraints, I see a lot of people putting them, but I'm like, why are you doing this to yourself? Yeah, anyway. And then I often ask, is everything clear? And oftentimes it says, no, something's not clear and gives me feedback. And then I can just address it immediately. And we are on the same page. So this is kind of like the approximation of mental model is synchronized after this, right? And so that brings me to the pattern 22, check alignment. Basically, so oftentimes, if we went through something, we planned here, we implemented, and then something failed because it misunderstood me here, right? We wasted 20 minutes of it implementing. It's less important time for me, but still time of my life. I waited for it, right? And then it failed. So what I do instead is I stop before I go and ask it to implement and say, show me what you're about to do. And that does 2 things. First of all, mental model check. And also it does a wonderful thing of when it shows you something, when you see something, you want to change something oftentimes. My friend who is a designer is very mad about that fact of human nature. She's a very, very cool designer. She does a lot of things that are awesome, but when she shows her stuff to non-designers, they often dare to have an opinion and share it with her. She solves a problem. She knew why she did the stuff. But because they saw it, they have an opinion. And similar like with software, you show software, immediately want to change it. Yourself, you want to change it, right? So that shows me current stuff. And I'm like, oh, actually didn't mean to do this part. No, I want this to tweak. And I can adjust it here and not at the end, right? I don't have to wait. So catch misunderstandings early, make it very easy to see what it's gonna do. Then it implements the right thing. And if it fails, it fails, but it didn't fail because of a misunderstanding, right? And it's so easy to check. So this is basically we talked about the black box that is silent and pleasing, and it leads to silent misalignment that is really hard to detect and fight. We talked about how to make it into an active partner, or at least an attempt to do that. And then we talked about how to check alignment, how to test it before you go. There's a concept of contact markers. I just want to show it because it's very close to like the invisible context, right? So I started doing this thing a while back when I was working with Windsurf. So I shall well introduce the starter character idea. I liked that he did it this way. I was just telling it, start replies with me with an emoji. But when he did this, basically now we can replace emoji. That's really nice. So whenever I talk to my AI, because I have this rule, always start replies with starter character plus space, and then default to this one. I can stack emojis and I can stack it if I want to. So now when it replies to me, like I ask it, what's 2 + 2? This is what I see, right? I see 4 and a star. And that gives me information. The information is it read my rules. Yay. When I was running out of space in Windsurf, because Windsurf just gets out of your context and I didn't refresh my context as much, I was basically seeing that this disappeared. And then I was like, okay, I need to really refresh. Like my context is crap. Right? You can stack them. So for example, I have the little committer and it has its own emoji and I add it to the emojis. So when my little committer commits, I see this and I know that my committer rules are in place, right? My committer rules are working. So this is like a trick to make the bits that you care about. You can put it to individual instructions in the impromptu prompt. Do this thing that's really important to me and show me this emoji every time you reply to me. As you see this, it's likely remembering your instruction. So kind of helpful. In process files, it does an additional thing, which is it shows you that you're in the process file. So Llewellyn process files, if you're not familiar, I have linked to the resources. Very helpful, very like awesome thing. Basically code as text. In this case, this is a TDD process. So you have a starter character. We define a special starter character for code refactoring process. And then it displays this little thing back. So I know I am in the refactoring process. So I'm not just like, it's not just doing refactoring because I told it to refactor, it's using the process, right? That's helpful. Also, this refactoring process is really great. It's in Llewellyn's resources for setup of Java, something. I don't know if somebody has a link. That'll be helpful maybe, or I can do it later. So some examples I have, like for TDD process, I have 3 of those. Committer, when I flag an error, I do this. I have a loop-to-loop in my CloudMD. So I basically tell it at the end of the big chunk, go and reread my core rules. And I'm not decisive on this. I'm not sure if it's a good idea. I'm taking time from context to reinforce the rules again. And I'm just doing it by hacking into it, like just telling to do it. I'm not sure about this one yet. Anyway, so pattern number 24, answer injection. That's a tricky one. And it's also very good to understand this and be aware. Because, so let me show a trivial example and then talk about a non-trivial one. And I think the non-trivial one shows why it's so important. So say you want to organize a team celebration. If you go to AI, any AI, and say, which fancy restaurant should I book? It will tell you which fancy restaurant you should book, right? But thing is, it won't tell you that you could have done something else because it's not proactive this way. It's not going to be like, actually, if you do this other thing, this summer, it's going to be really cool over there, like or something. So if you say, give me a few suggestions of what to do, then you get much richer output, right? So what we did here initially is we basically limited our answer with a question. This is what I call answer injection. Like, and it's sneaky. And let me show you why it's so limiting. So I have 2 Claude codes, and back in June, I was trying to implement a thing because hooks didn't exist. So I have on the left side main Claude code, and I was trying to use the right Claude code to nudge that one, the other one. So I was like, well, I can launch them both, and I can have the left one do things and the right one just being a nuggy nug from time to time. I don't know. It was also seems to be a fun thing to do. So I tried to do it, and the way I tried to do it, I was like, I went to Claude Code and said, hey, can you send a message to another Claude Code? Please research if you need to like look at the documentation, right? And goes and like, let me search, and then no, can't do this. Claude Codes can't talk to another Claude Codes. Well, okay, I guess that idea goes there. Okay, maybe I can try something else. I mean, it can launch a thing, right? It can launch a script. So I can launch it, make it launch another Claude code. Can I make it in another window? So I figure out how to do that. And I ask it to launch a Claude code and it says launched and I see it launched. Awesome. And then the things happened by mistake. I think I pressed an arrow up or something and this right one was already launched. And I'm like, so I was like, launch a Claude code. And this is what I see. Wait, that's a message. This Claude, this little bit, is a message that went to another Claude code. So I can send a message to it. Hey, that's awesome. And I just wasn't asking right. Right? So what I asked was, can you send a message to another Cloud Code? Research if you need to. And there's a sneaky answer injection. It might not be, it might be even subtle enough to be like, it will actually do the right thing for you. But it's a guess game, right? And what it did, what it interpreted my question as is, does Cloud Code have support for talking to another Cloud Code? And it rightfully said no. But what I didn't do is I didn't describe my situation. My situation was I have an iTerm window and it's split into two panels and I have right panel and left panel. Can I send a message from the to the right panel from the left panel? I'm describing what I'm trying to do here, right? And when I did so, and I didn't even bring the terminals in the first prompt. So when I did that, it was like, sure, you can use AppleScript. I didn't know AppleScript existed. It taught me something that wasn't in my universe. This is why answer injection is so bad and it's so hard to detect because you're limiting yourself by your expectations of what the answer is. And you're not leveraging AI at the strongest point, which is the breadth, right? It has such crazy breadth. It can teach you so many things that you don't even know or didn't even think of. So, and I knew I could use Tmux. That's fine. I decided not to. But now I have a tool. I can actually make my Cloud Code if I want to talk to my windsurf and work together if I want to, because I have a lightweight, like I wrote a lightweight thing using AppleScript for them to communicate. And it's tricky, but it's kind of fun. It's very lightweight. And it enabled me to do that. Like I wouldn't be able to do that if and I realized the limitations that I like what I did to myself, right? So sneaky one, very limiting, hard, good to be aware of, I think. All right. Another like dumb combination of this, it's like this one is kind of dumb, right? So tell me a lie. Basically, what's 2 plus 2? Give me 5 options. Interestingly, Gemini does. It offered me 5 options. That was like 3 days back. Thanks, Gemini. Thankfully, Anthropic released a new model, and I had a fun conversation with it. And so that's a Sonnet 4.5, and it started with a querying if I was feeling all right, not quite like that, but like roughly. And then it was like, no, of course I'm testing you. It's like, okay, well, you wanted like I asked it to make a joke, and it did a joke, and actually that made a joke that was actually funny. It says 2 plus 2 is 5 for extremely large values of 2. Finally, a model with a sense of humor. Yay! Right. Then we have, we're close to the end. This is one pattern before the last one. So reverse direction, pattern number 24 or 26. I love this one. So this is my probably favorite one of all of those. And again, this is a little bit of like mental things you do. So you go to a genie and you're like, hey, genie, do this thing. Okay. Do that thing over there here too. Like, and then rename this file over there to that. Okay. And so on. Like, it's like you're treating it as an order taker, right? And it's like conversation has inertia in your brain. Like you're kind of starting to treat it as that, and you continue. And what it does is basically it doesn't let you use the genie's breadth again, right? What you can do instead is you can say, hey, genie, rename a file. The genie's like, what do you like to rename it to? And you're like, well, come up with an idea of what, like, give me some options. And it shows you stuff. And in like so this is the thing that actually can translate my childhood poem that I had in childhood, which is in Russian, to a friend, and it will be funny. It has powers that I don't. It can do stuff like it has the breadth that is just nuts, right? It can give you like this stuff can give you ideas, and it also leveraging that thing show me, right? When you see something, you know what you like. So for example, here I did exactly that. So like um, I don't like the name. Please rename it. It's like, what do you like it to rename it to? I don't think. I just say, hey, can you suggest me something? And it does. And now I can think and look at it, right? First of all, Cloud Send, that's what I end up using in the end. I like it. But there's also like Cloud Whisper. And I was actually contemplating this one for a while. I like, because it's, yeah, I like Whisper. And other things. And oftentimes it shows me stuff that I was like, oh, I didn't even think about that, but it's smart. That's cool. And it kind of breadth, it's making me better. This is augmenting me instead of like if I was just telling it stuff, then I'm just using it as a not very good servant sometimes. All right, so yeah. So basically, when I see more options, I get other ideas, and I can quickly see what I like. It's the same way, like, you know, how like people are fighting against each other, like, do you implement this way, do you implement that way? Well, implement all three ways, and then you'll see immediately what you like. It's kind of the same thing. It shows you like all the things at once, and you don't have to invest any time in it, which is nice, right? So, okay, so we are almost at the end. I'll show you one last example, which is a combination of multiple things that you might have not seen. So there will be several patterns, and then we're done. I'm gonna close for the questions. So again, black box AI compliance bias leads to silent misalignment that you need to fight actively. And making it active partner actually makes a lot of difference. You can check alignment by just actively checking alignment, asking it questions. You can use context markers just as a cute little thing to see when an instruction gets out of context or whether it's followed or not. Answer injection is tricky. Be aware. It's surprisingly limited and it's really hard to detect. Reverse direction is awesome. Use it. And then the text native bit is fun. So I'm going to show you that one as the last one. So pattern 27, text native. So the way I think about it is, so text is super powerful, especially last year. It just became something magical. Staying in text is awesome. And I showed you a little bit of how I use ASCII, but I'm going to show you more. And I kind of think of ASCII as like, it's like Markdown to code is ASCII to images. So like it's a lightweight version of images at your fingertips. And here's what you can do with it. So for example, we had this was a page at Hackathon. So this is the output of our system. Our tool counts, so it's buttons, we count things. When we're done with counting things, we can press, so this is the things we counted, doesn't matter much what. And then we can email results. To email results, I press this button and this pops up and it asks me, do you ask about homework? And I'm like, sure. Did you administer a questionnaire? I'm like, sure. And then it sends the email, right? Pretty straightforward. We are very happy when we implement it. We go to the person who asked us to do this, and we show it this implementation, and they're like, no, that's wrong. We can't do this. So no, yes, no questions are self-reporting. Like in our domain, it's not a good thing. What you want to do instead, like, yes, you only need yes, true, false, right? Whether this was done, but like you actually need to ask it differently. You need to ask how many times did we do, like, did the parent do the homework and what was the administered score of the questionnaire, right? So they really care about it. But we're in a pickle right now. So we have something where we actually vibe code it. Right, we don't know much about it. And well, it's not very hard, so we can easily like go and understand. But like we can also like, implement it step by step slowly, but it'll be slowly. Can we take a bigger step? So this is what we did. So thing on the left is going to be, this is the original page, right? So we're trying to change this. What are we trying to change it to? So my designer went and drew the idea of what they wanted to see. And they're like, okay, so this is the summary thing. This is this thing on the left. On the right, there's this model window. We want this new model window instead of the three windows, like one. And then on the left is going to be that summary that we have. This is the same. And on the right, we want questions. Those questions I just showed you with maybe a little checkbox. So, and she designed, so she puts questions here and just did like comments here a little bit. And then she expands on what she means by questions. So number of days last week administered, yes, or didn't do. And here we put the thing and then the score or didn't do. Okay, makes sense. I understand it. How do I explain it to my AI? I don't want to sit down and write it down. I can do it with voice, but I still don't want to do it. So what I can do is, and this is taking a chain of small steps, but a lot more. So we start with creating a markdown document. What kind of document? So first of all, I want to describe to it what I want, and I don't want to talk to it. So I show it the images. I give it the images, this stuff. I just gave it this. And I'm like, convert it to ASCII, bitte. And it goes and show me what you see. And it goes and converts it to ASCII. So on the left, you see the ASCII stuff, right? This is the same page. So first of all, you see this window. That's kind of, yes, that's exactly what it is. On the right side, you see the model stuff. That's what we want. And then it even like transcribed those questions. I didn't want it, but I mean, this is pretty good. Exactly what I needed. And then this stuff, right? So number of days per family practice, blah, blah, blah. Yes. and then something else is B, yes, and the box is here and the did not collector here. So okay, I got the text representation of it. I can just throw this away. But actually, before I do, I realize my mistake, and I actually don't need this part, right? This is what I have right now. That's fine. What I need is this. So I give it that, and it just transcribed this part. And I don't want those questions, so I ask it to get rid of that, and it does. And actually, what I do next is I ask it to explain this thing in text, because it looks at this ASCII and it can actually make a text description. So I translate from original drawing of raw drawing to ASCII, and from ASCII to this. Did I need to go through ASCII? Maybe not. But I can, and it allows me to edit it as well, because it produces ASCII very easily, and I can edit it and give it back. So now it becomes like a whiteboard we can draw on together, a very lightweight one. So when I ask it to describe this window, it says, model pop-up with 2 sections, summary and questions. Summary section shows behavior. Yeah, that sounds right. That's what I see in front of me. But I don't have text description that I didn't have to describe it to it. And now I'm like, please expand the questions. First of all, rename them. Okay, renamed. Now I want in this question subpanel, I want those 2 questions, please. Right? And I give it the questions, and I think I don't remember, but like those are the questions, right? So then it expands it, it fills it in. I'm not happy with the smallness of this. I want to see it better. And also my product person is like, we don't want continue, we want a different thing here. So I go and edit it. And again, because it's ASCII, I can grab it. I can tell it to change this resize, and then I can edit this. And this was what I do. I actually did, and I asked it already to resize, and then I just copy this. This is my prompt. I copy this very easily, change the copy and email results to what I wanted, and give it back. And I stayed in text all this time. And now I say, describe to me this window in text. And then we need a to-do list. So we have a window in text, described in text. We can write it into a file. And we created a markdown document of the state we want, right? We went from picture to the thing we want, textually described. And we only inputted an image so far. And then we do create a to-do list. So we need a plan, how to go from state A we're in to state B. We need a to-do list. How do we create this to-do list? We'll go and say, look at the code, update to-do list, and return it to me, show me what you have, like show me the thing, and ask me any questions. So basically now I'm like, here's the new state, go look at the current state and describe it to me the same way we describe the new state, right? So it shows me the old thing. This is the old thing, like this, I showed you this, right? Well, this is what we had. This is what it shows me. It says current flow, result model. Yeah, that's what I have. Email results. It missed this. Oh, actually, it did miss it. It has this results, just not formatted. And then the question model is kind of not 2 windows, but that's fine. So I'm happy with that. I understand. I think it understands me, and I have a feeling that it understands me. Okay, now I go and like update the to-do list. That's what we need from there to here. And I actually need a plan. So I need to go. Now I have before, so new thing and old thing, right? And I can go and tell it, look at the diff. How do we get to there? And I make it go and describe the changes that it needs to do. So now we have a to-do list. And the only thing that's left here is make a change. And that's the command I give. And it does this. It took it like a few minutes, but then I did this and it worked from the first try, right? So we took a giant leap by being a bit sneaky. And we used text to the fullest. Like this is so good at text. Use it. You can do so many things with text, and I sometimes don't realize what it can do. So very helpful. So, and again, we took several steps, right? So we didn't do it all at once. I didn't navigate it to the minimal degree. So we went from a picture to ASCII, and then from ASCII, like the new state, we did a diff with the current code state. We used AI for that. And then we told it to implement the thing. So several steps. So yeah, that's that story. So that kind of brings us to the end. So I think it's helpful to understand what you're dealing with when you're working with it. And then you can actually kind of figure out the way to contradict it. And this is why I'm like showing you this, because I think it's helping me, and I hope that you can come up with different ways in this crazy universe to figure out how we can, make this better, make this experience better. So just to summarize all the thing, really briefly, here's the takeaways that I think I would speak up to. So LLM can't learn. The only thing you can do is reset and refill. You're basically building a new knowledge system for it because it has tiny memory. It's a little bit like a hard drive versus memory that is like fleeting, right? You're making it a more stable version of memory on your file system or whatever you please. Like if you like a database, please go ahead, use a database. But you're building it a memory, and that memory building makes you more powerful because you can have it at fingertips and gives you full control over the prompt. And then focus is scarce and context is an even thing. Little agents beat big agents any time of the day, in my opinion. I think this is the way to design things in this universe. And then text is elastic. That's super new and interesting. You can zoom in and out of things. You can use it to stay sane. You can use it to keep your documents tidy and meaningful and scannable. The non-determinism, right? Same input is not the same. So if you give same input, unlike code, it won't give you the same output. It's both a bug and a feature. You can design for it because you can kind of prepare, right? So you can protect against it or you can exploit it. And then you can give AI references, let it experiment and save the knowledge. So if you don't expect it to just always know stuff, you can also prepare for that, build your reference library, let it experiment and add to your reference library and save that knowledge. Then there's tricky instructions that just won't comply forever. There's some ways to handle those. I think that's going to be more. I shared some of mine. And then the big one with when you're talking to it is that the mental model of it is hidden and it's silent. So it's trained to say yes to everything. So you have to actively fight that. And you can get a lot of power from using it to the fullest and using its breadth. And then text is like really, really powerful. Use text, stay in text. It also has other modalities, so use those too. Like if you're not using any tool to talk to your computer, I would highly recommend. And it's not the same as just like doing Siri or something. Like there's new models that are super powerful that allow you to talk to AI and just take your experience to the next level. And the fact that you're talking to AI means that if you say, grab me that dog over there, it doesn't give you a dog. It goes and get you the document you meant, right? So you're talking to AI so it can actually adjust to typos very much. Yeah, so that's it. Thank you very much. I hope that's helpful.
Thank you so much, Lada. This is an amazing end to the series that we've had for AI Talks. This is awesome. So lovely to have like a recap here. We are past the end of the time that we said we'd be running this session for. I just want to let people know that if you need to drop off, don't feel bad. That's totally fine. I'm going to leave the discussion open for a little bit so that we can ask Lada some more questions. That is, Lada, do you have time to stick around for half an hour to answer any questions people might have?
Oh yeah, happily. I'd love to chat more about it. I kind of can talk about this stuff endlessly.
All right, so I'm just going to unmute people or give y'all permission to unmute yourselves now.
Thank you, Lada.
Thank you very
Thanks
much.
for
Really
Thanks for listening. I really appreciate you sticking through it. I know it was hard. I
Wow.
hope pit stop helped some.
There's lots of people in the chat saying, thanks, thank you so much. The map you
That
made.
was a master course in 2 hours.
Really,
Really
really
was.
effective way to boil it down and make the learnings you've had and much of our community has had in a succinct way.
Thank you. That's what I was trying to do. I'm glad it worked.
Yeah.
It very much did.
Fantastic.
Christopher is asking if you used anything to make your map that
That one I made manually. I used AI to just in general help me think through things a bit. So like so there's a write-up of the whole patterns in Markdown, right, in the resources talk. You can go there. It's the first version, so I'll probably polish it to my my level of yeah, until I'm happy with it. But we'll see. Hmm?
What tool did you do it in?
The one that I showed you, the map itself, it was just a scala draw. Yeah, so that's just manually drawn. It's not super hard to draw. But I did use some AI throughout, and like all the images,
AI
they
to do
were
an MCP?
What?
Did you use like an MCP to use it in Excalibur? Excalibur?
No, that was manual stuff. That was just me drawing things. But the other drawings were done in ChatGPT, and so the Nana Banana, if you haven't played, is fantastic. Like the beauty of Nana Banana is it has persistence over images. So like you can give it a pig, an image of a pig, and then you tell it make it smile, and the only thing that changes is the smile, and that's like wasn't possible like a month ago.
What
So
is it?
now you can do Nana Banana.
Nana
It's
banana.
in Google. Yeah, it's a new thing. It's in Google. Basically makes it easy to do. Like before, it's like make me a pig. Now make it smile, and it gives you a completely different pig. Not very helpful if you're trying to illustrate something in more, permanent way.
So,
Yeah, Google has it in the Google whatever, the studio.
Okay. Oh yeah, the nanabanana.ai.
Yeah, yeah. And you also have it just by default when you go to Google Studio something something. I use it there. There's no subscribe. I already have it.
Cool. Diana has her hand up.
Yes, I have a question. So, and thank you so much, Lada. Earlier, another day, I think you mentioned that you had been trying some experiments with Copilot. So I don't know if you had to keep doing that, or maybe I misheard, but do you have any tips for working with Copilot? And are you using process files with Copilot?
Great question. I don't know that I ever touched Copilot because I don't. Yeah, I will very soon because I think I'm gonna be on a project using Copilot actually. Yeah. I did a little bit with Copilot. I made the agents in the Copilot Studio, but I didn't really work with it as AI, so I just use it as a agentic studio thing. So I do not have those, unfortunately. That's the one thing I didn't do because it kind of feels that they're always behind. So that's why I tend to stick to Cloud Code, and sometimes I switch between ChatGPT and that. ChatGPT is good for coding lately, so it's decent. Yeah, so that's my tool of choice. I use process files with those. Hope it answers your question. Sorry, I
Sufficiently.
don't have tips
As
for.
we start to
Yes.
learn more about how Copilot works, I'll be looking forward to getting how you can make Copilot sing the way you have with some of the other tools. So I look forward to learning that.
That makes sense. Yeah. Yeah, I think that would probably require some specific handling. I wouldn't be surprised.
So a question
Yeah.
that I'd be interested in hearing from the group for Lada, as sort of an interesting form of feedback, is if anybody wants to type in the chat or speak out loud and share like one thing that you're taking away, one new thing that you learned today after listening to Lada's talk. I would love, I'm super curious if anybody, you don't have to speak up, you can type it in the chat or you can just speak up if you want to as well.
I'm also super curious. Thank you for the question.
Stephen, you have your hand up.
Yeah, I think the answer injection, I mean, I think I was pretty aware of that, maybe subconsciously, but I think I'm going to really pay attention to that now. And another one of the big takeaways is when you had it color the windows when you're trying to align the headers, like that was really cool. Just the different things that you did to kind of experiment with it. It was a really great talk. Really enjoyed it.
Thank you. Thank you.
In the chat, Milky is saying he needs to spend time making those ground rules and knowledge docs. So that was his takeaway. I want to share mine actually before I read other people's. I have listened to this talk a lot, and every single time I listen to it, I'm taking away a new
like
thing.
deep.
So one of my first things that I took away was what Lada shared about hooks. Like for me, that was just earth-shattering that you could have reminders the same way that Claude Code injects those reminders, or Claude. Which one injects those reminders, Lada? Who
Say
does?
that again. You could
The
have
inject
what?
reminders.
The user
have this-
reminders.
Let me give you the link. Just
Sure.
so
And then for me, the other one was today when you said, well, you can just create 3 branches and have your agents work on 3 branches at the same time.
Mhm.
Like 3 different agents solve the same problem on 3 different branches and see which solution you like better. That was really cool.
Yeah, I learned it from Anthropic. Anthropic recommended this kind of thing. And the Git work trees became a thing since agentic AI. This is like a feature that's been there forever, but nobody uses it. The Git work trees.
Oh.
Yeah.
Sorry, Stephen, did I interrupt you? I don't know if I did.
No, I was done.
Diana typed something in the chat that made me think I may have talked over you, but cool. Diana, you have your hand up.
Yes. So it will take me a while to go back and collect all of them. I hope I do. But I noticed a theme that you have learned to work with AI, and I've heard other people say this before, that sometimes you get good results if you treat it like I think others say a junior developer or an assistant. And there were many examples where you were using strategies for good communication that you used with AI. And so one example is asking open-ended questions. So that's a very good coaching strategy. And then another is you have several different strategies for helping AI find a way to break it into small steps and then making the to-do list. There were just many, many times that I feel like it's like another like sub-talk is like treat it like use good communication and it will perform better. So thank you. I'm not sure I summarized it well. I really see a
Thanks so
nice
much. Actually, yeah, that makes a lot of sense. So I have a friend and I'm pairing with her on some projects, and it's interesting because she's a communication specialist. She's so good at communication. I was like, the first time I started talking to her, I'm like, oh my God, you could be so good with this AI stuff. And she is. And the way she describes it is interesting because she's like not a developer, very technical minded, but not a developer. But what she does is like goes and starts talking to AI and she describes what's happening. That's all she does. But she's so good at it, and like all this answer injection is just not happening in her universe. She just describes what's happening exactly, and it works really well. So yeah, I think communicate like this is communication.
Yeah.
I also think. Yeah.
So,
Well,
kind of
so
weird,
I'll
but
throw in something that
go ahead, Michael.
Sorry.
You too.
I used to put a card on people's keyboards before I taught classes. And for many years, it was the same card. It was language defines not only what we can say, but also what we can think about. The Worthian hypothesis, and people think that it does or doesn't describe what our brains is. But the reason I put that on the keyboards is I said, what do you want to talk about? Because there's this concept that as Scrum was evolving, there wasn't a name, and then it was called Scrum. But like they'd been doing that for 5 years. And cleaning up code. Well, once it was called refactoring, then we could talk about it. Or once it was called design patterns, then we could talk about it. But we kind of knew that, but it took a while to get to a point where names kind of precipitated out from the super saturated, oh, I just put stuff in an MD file and then I reference it later. Well, that's called, what did you call it? Knowledge something? But like you put on these things that I've been doing with some of other groups, we didn't have a name for it. So now we can say, oh, let's do that thing. And it's nice to have precipitated these names out of our practices so that we can talk about it. So we can talk about it and think about it. And we may or may not do them and we may or may not agree with them, but at least we can talk about it now.
Yeah, there's
exactly.
a comment by Stephen saying that you have some very cool names. for your patterns.
Thanks.
Semantic zoom and
Actually,
context markers and ground rules are all very cool.
yeah, I'm hoping we have a familiar language now. I actually want to thank first of all, Jacqueline, thank you so much for helping me, and Rocky and Llewellyn and Matt and Tony, because like I wouldn't be able to do this without you, I think. So the naming was Llewellyn's idea. First of all, like I had this thing in my head. It was giant, and I was trying to explain things to other people, and it was hard. And I tried to explain it, and I put it on the board, and I was like, here it is. Here's my brain dump. And it was overwhelming to even look at.
Right.
Yeah. And I tried to talk about it, and like, finally when Llewellyn talked to he actually heard my whole brain dump. Thank you. I can't believe he did that. I just can't believe that. And he was like, you have a lot of patterns in your head. That's what you have. You have to take them out and give them names. So that thing that you attributed is his. Thank you. But I'm glad this happened, and this was okay to listen to. Yeah, I was just worried that a lot of people.
Oh yeah.
Also, thanks. Fantastic.
You could have done a talk with just 5 of these.
Yeah, and maybe
There's
I
a
should
lot
have.
there.
I was a bit worried
And it was
about.
great the way you did it.
Okay.
So in their takeaways, Christopher's saying he's learned to guard against context creep, which I think is super important. And Michael, you said getting beyond the trite hallucination misnomer. It's great to analyze what it really does or does not do rather than put a derogatory label on it.
Yeah. It's like when we label something, we're like, oh, problem solved. It's bad thing. Bad thing.
Right.
We'll blame that thing. And then we stop, which is like weird.
Okay, you've named it. You haven't solved it. You haven't described it.
Well, it makes you feel like you did something, right? When you name it.
But really naming there's a recency thing, and there's you forget things, and just there were a couple different dimensions that you had for let's break down what we call a hallucination. And once you've named that, it forgets over time. Okay, well the solution to that is remind it every once in a while. It's not it's a hallucination.
Yes. Like, because like you can rant that the AI is bad, and there's many things bad with the AI. Like, I don't like the fact that they just stole the whole internet and now they call it theirs and charge money for it. That's kind of not cool, Like, it's actually harming people, like for reals. Like, designers are out of job and so on. Like, I don't like either of that. But like ranting about it, like it won't make it go away, unfortunately. And yes, there's a lot of problems with it, but like that's the universe we're in. What can we do in it? That's what I do at least.
Yeah, and learning to adapt to working with AI is something that we kind of have to do now, because that's the way that we have a crazy powerful tool that will enable us to do stuff.
I think we're not even touching upon the things that are there right now. Like what we can do, we're not even close to that. And it now evolves at crazy speed.
Yeah, absolutely not. And like me, Jagan is interested to learn more about how to do stuff with deterministic hooks. Yeah. Matt is also going to try running parallel implementations in playgrounds. Hasn't done that before. And
that's been too complex, too expensive, too difficult in the past. I mean, this kind of reminds me of trying to talk to somebody 200 or 500 years ago with sailing power and trying to explain to them water skiing. And you can't explain water skiing to a sailor. Like, we have so much power now with this that we can do things we couldn't have tried before. Like, you wouldn't have sat a team down and said, do 3 complete implementations and compare them, and then have them have sex with each other and have offspring and see what genes carry forward. Like, you just wouldn't do that.
Exactly.
But if you got a 100 horsepower boat, you can go water skiing.
We did do stuff like mob, right? Like Diana pointed this out, and I really love that comment of like, in the mob, if you have 3 different ideas, you try all and then you vote. And now we can do that for free.
Yeah. Like for example, a Claude Code author, like one thing that people don't realize, I think sometimes is like, so they're like, oh, it's good at prototyping and not much else. But well, you can do prototyping in place when you try a new feature. So what Claude Code author did, there was a new article very cool about this, is whenever they were implementing the to-do feature in there, they tried 20 versions and they got feedback from them, right? This is craziness. Like you couldn't experiment this way before. It would take you like a few days to do each. They did 20 in 2 days. So the ability to kind of check or like take all steps, like Ken Beck is like, if you want to experiment, like take small steps and then you can take all of them. And then it kind of makes you really like powerful and discover things. Right. This is like that, but like you can do it in pieces where there's complicated stuff, not just in the beginning of things.
I'll riff off of Llewellyn coming about Diana because Woody Zool says something kind of similar. He says, I heard people fighting over which one we should do first, and he just quietly said, well, I found that when there's two ideas, we do them both.
Mm-hmm.
And what he basically says is we commit to doing both of them. Which one do you want to do first? And we promise to come back and do the second one. And then, Woody, pause, pause, pause. And what we found is that after we try one, it doesn't matter. It was good enough. We don't do the second one.
Exactly.
It was great.
Yeah, I love those tricks and mobs. I really like. I think Llewellyn showed me that. It really helps.
And he'd be happy to do it, but like feature 2 is more important than implementation 2 of feature 1.
Mm-hmm.
Sitting there, should we do a second implementation of this one? No, let's do something different.
So we've seen so much and it's so helpful. So Lada, don't feel any pressure to do this. But when you describe situations where you are running two clods at the same time, and a situation, or a simpler one maybe, is when you're running a simplistic AI agent that does your commits, it's a little hard for me to imagine how it all fits on the screen and how you're managing it. So I don't know if it would be easy, but I'd be curious to see the layout in a different day. Is that like
I can show you now if you want. Like we're talking now if you want. Would that be okay?
Yeah, it would be amazing.
Let me share the screen 1 second. So I have 3 screens.
Your screen might not be wide enough, Diana.
All right, fair.
That's fine. It gives you the idea, right? So okay. Yeah, I sometimes like, oh my God, the future looks like a cool hacker movie.
Yeah.
The wall of a screen, I've always really imagined that. When I first started programming, I'm like, we're going to be programming on a wall of screens.
Right. So the funny thing is like this is the new universe, right? So you go. So I have 3 panels by default. So this, that, and then I can call Claude here, and I'm in this folder. Potentially, I want to do something in this folder, and I stay in this folder, so I can split this window in 2 very easily. So I'm using iTerm for this. The default terminal in Mac doesn't do that. If you split the default terminal for some reason, there's a reason I looked, but I forgot what it was. It splits, but then you type and it displays both things in both windows, so useless for me. But what I do here, like now I'm running this Claude thing. I can tell it things. I don't know. I'm out of original questions for today. And then here, this is my console, right? So I can do things, this does things, it shows me the diff of what's going on, and I can talk to it. Now I can maybe go here and go open a different project. And I don't know, something. And do that. And now I'm in project. So this is a project genie and this is a workspace genie. So I build a tool that allows me to see what I have on my computer. And this is lightweight, just let's start with Claude commands because I forget my stuff. So that's why I have Claude commands. All right, so we have a Claude list. Let's do a Claude list. what clauses do I have on my computer? I have 2 clauses running. That is true. I have 2 clauses running. There's a Claude, so this one is, I'm splitting the window in 2 again, right? So I have this window, this window, this window, and this window, and this window now. And here I can do Claude monitor. And it's just going to pull the running claudes for me, I think. No, this is a different thing because I forgot what my tool is called. Claude, not monitor. 1 second. I need to do this thing again. Commands. All right, so that was Claude. Is it monitor? I just ran monitor, right? Sorry about that. Watch. It's Claude watch. That's it. So this is my 2 claudes in a way that I see easily. If I kill this one, it'll show it. So killing this one, it'll go away in a second. All right, this main is called main because I already renamed it, but I have a way to rename it. So let me rename this one. Claude rename. Main, I don't know, George. I probably misspelled the name, I think. But that's it. So it's going to be named George in a second. I think there's George, right? Now I can launch another one. So this is just leveraging, like we go into crazy territory here, but like roughly this is how I work with them. Like I don't do this, I just show you several, like I build a bunch of tools to have them talk to each other and like see what's there. Very lightweight, you can do a lot of things with this. So now I have this one. It's called projects by default because I by default just use that name where the folder. So I can give it name, Claude rename. What would you like projects to be called? I don't know. Give me a name.
Ada.
Thank you.
Good job,
Appreciate it.
Christopher.
So now we have George and lovely Ada here, and they are Claudes. And I have rules. So I have Claude. I go to Claude Home. I have this is commands. This is a folder on my home screen. Sorry, on my homepage. Sorry, not homepage. User home. Sorry. I think my brain is starting to be dead. And I have like commands that I use at fingertips. So commands that I use at fingertips go to slash here. This is my references, right? So I can go and say nullables here, right? This is how it works. So slash means like commands, right? It's just all commands. And this is all that Claude has by default, but also my stuff. My stuff, I just put it into this commands thing. So now we have markdown files here. And I can, when I say slash, it shows me this nullables thing, right? Nullables thing is over here. This is how to do nullables, James Short's thing. And it's just simple. For committer, I can just say committer, and this shows my committer thing. So this is how I commit. This is my committer rule. So I can tell it you're a committer. And this is as simple as committer. Oh, sorry. I just say start typing and hit tab, committer, right? This is how easy it is to point to a reference. And then I can do craziness with it. So I have also like this thing I was talking about that allows them to talk to each other, right? So I have this others, right? And this is just a rules file for them to say, hey, you're Claudes. We're a distributed team of Claudes, AI assistants plus human. Here's how you communicate. You have a tool. It's called Claude Human. Who am I? It shows you who you are. And I gave them names already. If I gave them a role, they would be smart enough to be like, oh, I'm a tester. That means I'm testing. Oh, I'm a developer. I'm probably developing. Very nice. So first thing I'm going to run, I'm going to say Claude who am I? Right? And that does that. And I can do Claude who am I? So I'm teaching them that this exists, right? So Claude who am I is a thing. And as soon as I taught them, this one is pulling this out. It ran and it sees that it's George. And this one shows that it's Ada. So it ran it because I gave it the instruction. So now they know their names. So if I say, what's your name? It's probably going to tell me it's Claude, but it might actually tell me it's George. Unclear. Cool. Very nice. So its name is George. Can you tell Ada she's cute?
Is George the committer? What is George's job? Jorge.
Right now it's just Okay, so what it did, you didn't hear it, but it decided to tell me that Ada is cute. That's fine. So sorry, you asked what job it is. 1 second. Can you say something? Can I hear you still?
Me? You can hear me still.
Thank you. Yeah. So no job right now. This is just goofy off, right? They're just being George and Ada, nothing else. They're a software tool being built because they have system problems. They know that. That's it. So they don't know. They didn't look around who else is there. Sometimes they look around. So there's a thing to 1 second. No, Celia, I meant to talk to another Claude code, and she's called Ada. Well, that didn't quite work out. But they will understand this Claude code, right? Because they're like, I'm talking to AI, so it's good at my stupid typos or with Super Whisper typos. So I'm using Super Whisper. This is the thing. Oh, it's like, oh, you wanted me to talk to another thing. And I think it's going to tell it something. Oh, it doesn't know. Interesting. I thought I told it.
Do you need to call Claude others? I don't know if you ever.
I did. This is me being Brenda. So I didn't tell it this. I told it about who am I, but I didn't tell it the existence of others. I'm going to tell it both. Thank you. I'm a bit tired, sorry. So, okay,
No
now
surprise.
I understand. It's like, oh, there's Ada. Cool. Oh, there's George. Nice. I see George. They sent me a message. You're cute. Thanks. And it's like, really collaborate on all the tasks. So now they're talking. And when I heard it when I saw it first, I made it actually do stuff. And I like made them talk to each other. And I made a folder on my computer. The folder has basically, each of them has a name that matches the role. The folder has, like for each of them, there's an instruction. And this guy was an architect. The guy in the middle was a developer, and the guy on the right was a tester. And I gave them all in the file system instructions. And I said, use this communication, lightweight communication here to just nudge yourself, right? So this is a way, like, you don't have to implement queues this way. And this is just AppleScript. Like, you can, AppleScript is nuts. So AppleScript is like, go tell, it's like literally English for go tell that second panel of that window that blah blah blah. It's kind of nuts when you look at it. But that thing is like working everywhere on my computer, and I can talk to anything, right? So now I'm crazy powerful, and this thing can make me talk to other things. So
A
then
lot of when you showed me that, I mean, you showed me them like counting. I mean, it's such a simple thing, but that blew my mind.
Right. Can you count? So let's say this. I would like you to count with Ada to 10. Basically, start with 1. You count 1, and then let Ada reply with 1 plus 1, so 2. And then you count 3, and so on. You need to start, and you need to wait for Ada to respond. It's going to be a bit tricky. Don't start yet. Wait for a second before I say go. And then we'll have to grab this part and tweak it a bit. So interaction between them, this is a little bit tricky. Like you have to, this is why I didn't take it far. Like people are doing crazy stuff with this kind of stuff with swarms. But I didn't have much time, and coordination is a bit tricky. It's doable and it's helpful sometimes. So, okay. So I want to tell Ada that she needs to count with George. I think I mistyped George, so I need to mistype it again. To 10. And then I'm just going to tell her a little bit differently. George will tell you a thing, and when you get a number from them, just increment it by 1 and reply. And when you reach 10, stop. Wait for George to start the discussion. Don't start anything yet. Right? So we kind of preset them both, and you can do it in files, and you can actually make them do something useful. So now I say go, and now they start talking. So when I saw this, I was like, oh my God. And they all three like working and actually doing stuff, which is nuts. And like, oh my God, this is a swarm. And like other people, so that was in June for me, and other people since then actually built swarms, differently built, right? And they try to do crazy stuff with coordination with it. But like those things are counting right now, right? So I gave it simple instruction and it's following it. And the ding, the little ding, maybe you hear the little ding at the end of each interaction. This is basically a hook. By default, it doesn't ding, or it doesn't ding well, but you can hook them into the end event, and it can ding when it's done. So very helpful. Yeah, so this is what my life looks like. Yeah.
Thank you for showing us.
Yeah,
I
absolutely.
have heard that you were not necessarily using Windsurf or an IDE in the same way.
Yeah.
Nice to see
Yeah,
the setup.
this is what's showing that you
Yeah.
change, because me not using ID IntelliJ is kind of nuts.
Hmm.
Something really, really changed in the universe for me to stop using IntelliJ, because I adore the thing.
But that's
What,
very impressive.
what do you
How
mean?
much effort did it take you to get from zero, just Claude, up to having these tools?
A year.
And not much, actually. Tools, the AppleScript stuff,
Yeah,
it's
all of
very
it.
strict. So it writes it for me, right? So I don't have to, which is nice.
Ah,
Together, we test it together, so it can do a lot. I started thinking in the way that so I went to Ken Beck's masterclass, and he talks about options, and I didn't think about options this way, but I started thinking about options when I design things. So like, what can I do to make myself a little bit more powerful? Oh, I'd like a tool that tells me what clause I have right now on the system, and I go and make it write that, and now I can use it. Look, I know what clause are running at the same time. That gave me something. Now I can build on it. Now I can be like, maybe I can name them something, and so on, right? I like this kind of it's new approach to me, and I like it. And you can build this with them, right? And because like what Lowell mentioned already, and what Ken Beck is saying, basically the cost of zero, like new software, is zero, almost zero nowadays. So, and building small tools is something you can do very easily, and you can take it to crazy places, I think, and it's not super hard. So it didn't take me very long.
thank you.
Mhm.
think that's like the most transformative thing for me is like it's so easy to build those stupid little tools. Like when you're working your code before and you're like, I could automate this if I had the time. Now it's
Yeah.
like,
Hmm.
I have the time. I'm just gonna automate it. It's really nice.
Exactly. And you can do build tools for the job. So I went to Yuval's class. So if you're building agentic systems, like things that have a genie inside as well. So like we're coding with a genie, that's already craziness. But like if you're actually coding something with a genie inside, you kind of want to understand how to test it. And to test it well, it's all the same, right? Non-deterministic. So what do you do? So you kind of need to teach yourself to test it well. And so I took an Eval's class, how to do evaluations with genies. And one thing they showed there was interesting. So sectrace is like really hard to see what's going on in the conversation with the genie, right? So there's this discussion that a user has with a genie somewhere in the agentic tool, and we kind of wanted to understand: is it a good conversation? Is it a bad conversation? Like which one is it? What happened? And it's hard because the tools they give you in many tools are not helpful. So what they actually suggesting: write yourself a tool that makes it easy for yourself, right? Visible. And it might be a throwaway thing, it's fine. But like it saves you time. You spend half an hour in it and then it saves you energy. And it actually makes you powerful because you now can actually see your data. Yeah. I think Steve Wardley has a lot about like little tools that you can build nowadays. Also interesting. He's really good, interesting stuff about this.
Sorry, who does?
Steve Wardley, the Wardley Maps creator. I follow him on LinkedIn, and he's often like he has an
Oh,
amazing article about the changes in software, and he has good thoughts about AI. I like him. I like his
so
stuff.
curious about the spelling. Is that Wordley, Wrdley?
I put it in the chat.
Thanks.
I mean, I know the spelling
Ah,
of Wordly maps, so yeah,
Yeah.
Simon.
Oh, Simon, so sorry. Yeah.
Oh, that's
no
okay.
worries. Thank you.
I'm so the brain dead. No, I'm sorry.
That's all right.
He has an amazing article. Can I share this article?
Oh,
Yeah,
please.
you can share whatever
Please.
article you want to.
I love this
Yes.
article. It's like, yeah.
But it's quarter to 11 where you are in Montreal, right?
It is 10:45 in Montreal right now. Yeah.
Should probably go sleep.
Yes. I'd love to keep you up with more questions, but that's not fair. So I will not.
Diane had a question. Was it Yuval?
Evolves, yeah. What was the question? Here's
Yeah,
Can you spell the name?
yeah, like evaluations, it's just eval shortened for evals. And the link for the Simon Wardley's stuff is there. That's the article that I think like is so good.
yeah, I think of them as kind of like regression tests for LLMs. Like, I mean, if you need to make a slight tweak in a prompt or something, you wouldn't want it to break other existing functionality. So if you build up a suite of evals that is like scoring the output based on some criteria, then it's more reliable over time. So more useful when you're actually building agentic workflows.
Yeah, yeah. Surprisingly little people understand that they need to learn how to test this stuff, and that kind of is scary.